Hello, hi, how are you doing? Today I'm going to read about the, one of the articles from Hugging Face. We are opening, we are open sourcing our text to image model and process behind it. The article was released in November 12, 2025. Before that, I was randomly searching the article and I came across this training design for text to image model. And when I was reading it, is said this is was the second part. So before that, before reading this, I should get preliminarily what's it about. Yeah, article about. So I'm reading the first part of it. Okay, let's get good. Uh, let's get let's read it. Okay. We have been training our text to image model from scratch and are excited to share the first result PRX and our open source model now available in Diffuser under Apache 2.0 license. This release is just the beginning. The idea is to make the whole process open, not just final words, how you train, how worked, what didn't, and all the details that usually stay hidden. We want this to become the one of the strong open model and practical resources for anyone interested in training the text to image model from scratch. Over the next week, we'll share this series of posts going deeper into the each part of journey, from designing, experimentation, and architectural benchmark to acceleration tricks and post-training methods. The first part of this series is already available, and with more coming soon. Try it out. Uh, we can directly try it out using the diffuser.pipelines.prx, importing the prx pipeline from diffuser, and the model loaded in the pipeline is Photoroom PRX 124 T2I beta, and the type is bfloat 16, and pipeline is loaded in the CUDA kernel. That means it loads the model as well as the preprocessor in the pipeline. Both model and preprocessor are being loaded, and all the logic is consolidated at the same at one class instance. Okay, and we are giving the prompt of front facing portrait of the line in the golden 7 at sunset, and image, the generated image given the prompt, how many number of inference we want to do for that prompt. The more inference step, the better the quality of the image, and it will also comes with the more resources. Guidance skill means how the generated image should look like, means how the generated image should follow the guide. More guide number, the better it goes close to what we are telling it to do, and less the guidance scale, it will generate a more diverse image. Yeah, give me the prompt. Okay, you can browse all the collection which include the different variant of the model, base, SFT, distill segment, and multiple BAEs. BAEs means variational auto encoder. Most of this model are 256 and 512 pixel model, but we have included the preview of upcoming 124 pixel model. Preview of the pixel model. Yeah, early result. Here are the few examples from 124 pixel PRX segment, a preview version of upcoming high resolution model. It is quite high quality image, if you say. Yeah, the image comes from 1.3 parameter PRX model trained for 1.7 steps at 124 pixel resolution in under 10 days on 32 yes 200 GPU. This particular segment uses REPA with Dino P2 features Flux BA and T5 Gemma as the text embedder. Below you can see the animation from audio segment during the training, all generated from the same prompt and seed, showing how model evolves from the scratch. Mm. You if you look at the hand motion, that you can see the uh, when it was training earlier, the hand fingers were more congested, not looking real, and more artifacts. Yeah, six fingers, finger blending. But as time goes by, you can see the improvement over the phases when the model get trained. Yeah, for goes to when model trains for a longer period of time. Yeah, for a longer inference period of time. What we have done so far. The first words are a result of the week of experimentation, trying to refine a training recipe that is both efficient and high quality. Here is summary we have explored so far. Architecture, DIT, UBIT, EMMDIT, DITTR, PRX means Photoroom experimental, our own and efficient EMDIT like period. BAE and text embedder, Flux and DCAE, BAE, and T5 Zema for text encoding. Training technique, REPA E, constructive flow matching, trade, uniform rope, immiscible, and muon optimizer. Post pretaining, distillation with LAD, supervised fine tuning, and DPU. Implementation DP details IMA precision settings and extensive hyperparameter sweeps. Uh, I don't know much of. I don't understand much of the architecture and the model variant. Okay, I have to learn it. And next, we run the extensive experiment to understand how these design choice affect our coverage, visual quality, efficiency. We'll go into more detail about these experiments and what you learn from them in series of posts. Deep dives, our training and research series. We have also started publishing the detailed blog series that breaks down the full training pipeline and all experiments behind the PRX. This is meant to be complement that release and document the process in open and reproducible way. Part 1 architecture design, part 2 design training design and accelerating training, part 3 post processing coming soon. We will continue adding to this series as we refine the training recipe and push toward the next generation PRX model. What next? The post makes though this post marks the first series of research object and releases we are planning. There are still plenty in the pipeline. We'll continue the expanding the research series with more experiment, evaluation, and model variant. We'll continue the training and prepare in the release of the 124 pixel resolution model. We started exploring the preference alignment through supervised fine-tuning DPU, GRPU methods such as pref GRPU. We are also looking into the recent approaches like representation, autoencoder. We will keep iterating, releasing more weight, and documenting the process along the way. Interested in contributing. We set up the Discord server for more regular updates and discussion in the community. Join us if you like to follow the more closely or talk to DTL. If you have any idea you want to explore a contribution you like to make, you can either message on Discord or email zone@photoroom.com. Glad to have more people involved. This project is contribution from the team of engineering, data research, David Vetron, Roman Frake, Simona McGeough, Lucas Gistin, Marco Forte, David Bryant, Thomas Bordier, Matthew Tolomant, John Alamajian, with the earlier contribution from Quentin Desrumaksh, Taket Ahid, Antio Diange, Benjamin Lifaudix. We are hiring for the same error. Okay, sorry if I gave your pronunciation of their name wrong. Okay, it is will be quite interesting because they are doing the elimination studies as well as they are releasing the how to train the model. It will be a nice resource for those who are starting, for me also. Okay, this is for now. Thank you for watching.